Our session today will be on hypothesis testing. Hypothesis testing is basically a topic that looks at testing assumptions and opinions subject to statistical proven formulas and steps. So before we go through this question, perhaps it would be important to understand what hypothesis testing really is, to understand its importance in decision making, and how to calculate. So let's begin. What is hypothesis testing? It is simply a statistical method that is used to make decisions or inferences about a population parameter based on sample data. So hypothesis testing helps us to determine the results that are due to chance, the results that are due to effect. So it is there to test the actual difference that exists within the population parameter. For instance, you have been using fertilizer and you want to switch to organic. Fertilizer gives you 20 tons. Organic fertilizer or natural manure will give you 19 tons. So is the difference significant because you're looking at the cost differences. So that is what hypothesis testing is all about, testing whether there's a significance in those changes. You are a company, you produce mealie meal and you claim your 25 kg bag is actually 25, but a client comes and says, actually, it's 20 kgs. There's a 5 kg missing in there. So that difference, is it worth being sued for? So statistically, that's why hypothesis testing is there. It's important for making what business decisions, quality control, for medical and pharmaceutical research. It is there for economic policy evaluation, manufacturing, and engineering. That is what hypothesis testing really in its applied context is all about. All right. So these are the main areas that we must consider. Now, hypothesis testing has formulas that we need to understand. And these formulas, we must master them or know them. And also, there are tables that we need to also understand how to read. So some of these topics are interrelated. So I'll explain a few concepts based on the topics that we've already had in estimation and sampling for those that are attending this class for the first time. So there are terms like population. What is a population? A population is simply the entire set of items of interest, products of raw materials, A and B. The GBS 541, that is the entire population. And the sample is simply a subset of a selected um, structure or frame of analysis. For instance, the 8 of you and 9 of you are a sample from the entire class. Then parameters that we want to test, we have the mu and the standard deviation. These are simply numerical summary of the population. So in terms of mu, it is the same as X bar, which is mean. This is a population standard deviation, and the small s is actually the sample standard deviation. So these ones are summary that you actually compute from the sample. So when you're calculating X bar, you're calculating standard deviation, they have a sample size what attached to it. So when you're writing your hypothesis, the format that we use is step one, you need to state the hypothesis. Hypothesis comes in two ways. There's what we call the null hypothesis, which assumes there's no difference, and the alternative hypothesis, which assumes that there is a significant difference. So we have the confidence levels, we have the significance levels, we have the alpha levels, and we have the Z values, which we can either calculate from the table or just memorize them here, there, and then. So we have four common confidence levels. Can we go through our sum? 99, then what level follows?
98,
Then,
95,
then
90.
the difference from 100 is what we call the significance level. So what is the significance level of 99?
0.001
1% or
plus 1%.
0.001. Yes, 0.01, not 0.01. When you divide it by 100. About 98%, what is significance level?
2%.
Or 0.02 when you divide it by 100. About 95%.
5%.
Or 0.05. About 90%.
So 10%.
Or 0.10. So what we have there are simple differences from 100. 100 minus 99 is 1%. 100 into 1% is 0.01. 100 minus 98% is 2%. 2% divided by 100 is 0.02. 100 minus 95% is 5%, and so on. Our key values of interest here are the Z values here that you need to memorize. So at 99%, what is our Z value? 2 point what?
58.
57.
575 or 58, yes. Then 98, what is our Z?
2.33.
2.33, correct. About 95%, what's our Z?
1.9.
And this is a standard one, okay? The most common, 95%. Then final 90%, what is our Z?
1.645.
1.645. So these are our Z values. Then what is the formula for the critical value of Z calculated for a sample? There's X bar minus what? The population sample mean over standard deviation times square root of n. Then for the population, what is our Z calculated? Proportion P over PQ over N. So we now want to calculate the Z. The Z is simply a difference between two values. Okay, step one, you need to what? Set the hypothesis. Step two, you need to set this level of significance. So state hypothesis. Step two, you need to do what? To state the level of significance. Step three, you need to make your decision rule. Step four, you need to calculate the critical value of Z. Step five, you need to make the decision. So these are the 5 steps that you need to follow through a complete, comprehensive hypothesis testing. So testing basically is about the differences. So at 95% confidence level, given a mean of 20, okay, which was calculated from a sample size of what? 86, with a standard deviation of what? Of test the 95% for a mean, which we assume to be 25. Population mean is 25. So the 5 steps that we're going to follow in here are simple. Number one, state the hypothesis. So our hypothesis is simply based on what? The population mean. So you say HO and H1. Our HO assumes that the mean is equal to what? 25 or 25. And our H1 assumes that the mean is not equal to 25. We say not equal to 25. So the population mean is what we're testing. Step two, state the level of significance. At 95%, what is our level of significance? Level of significance is what? 5%. It's a small percentage from 100. Okay? So significance level is 5%. So at 5%, what is our Z? Our Z is what? 1.96. So this is what we use in making our decision rule. So our decision rule using our Z of 1.96 is as follows. So the critical values, EA put negative 1.96. On the right side, you put 1.96 positive. Then you say we reject HO if it's less than 1.96 or greater than 1.96. So this shaded region is called the rejection region. It is a point where there is a significant change. So when your answer is in the rejection region, it may mean something good, may mean something bad, but the issue is here is a statistical difference. It's called the rejection region. So we reject our HO. By rejecting HO, we mean we accept HA or the alternative hypothesis. This is accept region.
Sorry, I'm unable to see what you are writing.
Is it the same with the rest? Maybe it's your internet. Are you able to see what I'm writing?
I'm able to see them.
Okay. You can
Let me move out. I come back.
you can exit and join again. Okay, sometimes internet may fluctuate. So reject HO if Z calculated is what? Greater than 1.96 or Z calculated is less than negative 1.96. So together on making the decision rule here. Any questions at this point? So if we had 98% here, confidence level would have gone here 98% same as 2% level of significance, which is 2.33. So here we would have put 2.33 negative and 2.33 positive. If they gave us 90%, that would be 10% level of significance. So we would have had 1.645 on the left and 1.645 on the right. Are we together?
Yes, so where are we getting the Z values? The Z
These are
values.
values
Where
that
are we
I
where
asked.
are we getting them from? Because I understand.
You can read them from the table, but we memorize them to say these ones are the standard ones that will come here. Okay?
Oh, okay.
We need to memorize them. It's easier like that. All right?
All right. Okay.
Okay. So these are the critical values. Then step 3, we need to now calculate the Z. Step 4, what is the Z value? A Z value is X bar minus mean over standard deviation. So we want to see if there is a difference between the two means, then we mean we reject HO. So HO means in an applied perspective, there's a claim that 25 people die at the mines every year. 25 people die at the mines. So the mine is giving a report. So you, when you went there, you actually find that in fact 20 people die every year. So you want to test the 5 difference significant enough to say they are lying or not. So our X bar, which was actually calculated from the 36 mines, we found that there were 20, minus our mu, which is what? 25. Then our standard deviation, which is 12 over square root of n. Z is usually used when n is greater than 30. So 36 here. So 36 square root is 6. 6 into 12 is 2. So on top, we're going to have 5. 5 over 2 negative. That is 5 over 2 is 2.5. So our Z calculated, which is a critical value, is what? 2.5 negative. What's the 2.5? Is in the rejection region or it is in the accept region? Where's the 2.5 if you see it from the illustration? It is somewhere here, right? So what is your conclusion? Number 5, the conclusion is what? Since Z calculated is less than, put it in brackets if you want, negative 2.5, is less than what? Negative 1.96. What do? We reject HO. And what is the meaning of that? reject HO, there's a significant difference in the what? In the means. Okay. Here the means a significant difference is there. Here there's no significant difference. All right, so there is a significant difference in here. That's what it means. So I'm starting from the basics before we go to are we together so far? All right.
Yes.
So now we are still learning. So there are two types of hypothesis. We have what we call a two-tailed and a single-tailed test. When our dealing with a two-tailed test, that's when we memorize those things there that we're talking about. So we have a two-tailed test. The sign that we use is equal to the one-tailed test. We use a sign which is greater. So a two-tailed test is used when you're testing for any difference, can be an increase or a decrease. We have a right-tailed test when we are testing the word greater. Okay, when you're testing the word less than, being in the hypothesis, that is a single-tailed or a left-tailed test. So we have, when the question is silent, it's saying test if there's a significant difference between the two. All right. So there is, that is how we get it. I hope we know how to read the tables by now. I hope we know how to read the tables by now. So let's look at another example here for a single-tailed test. Quickly, just give me the Z levels if you have memorized the song. 99, especially the newcomers, then what follows? 98, then 95 and 90. What are the Z values for these ones? Let's start with the last one. 98 is a Z, 1.645. About 95, what is a Z? 1.96. All right. About 98, what's our Z value for 98? What is the Z for 98?
That's 2.33.
2.33. Okay. Then what is the Z for 99%? 2.575. Suppose we're given our null hypothesis that our mu is 100, and our tentative hypothesis, our mu is not equal to 100. Then we found our X bar is sample size 104. Okay, and our sample size, we had 81 samples. The standard deviation of 18. Test if there's a difference at 99% confidence level. Okay. So the hospitals are claiming that only 100 people die out of COVID monthly. Then we sampled 81 clinics with a standard deviation of 18, and we found that actually 104 died Is there a difference between the two, or there's a negligent? Step 1, state the hypothesis. Step 2, state the level of significance. The level of significance is what? 1%, right? And 9 minus 1, 1%. Step 3, state your decision. 1% for Z is 2.58 or 2.575. So if anything falls within here, 2.575, we reject. 0.58. If anything falls in here, we reject. Okay. The positive side. Then step 4, we calculate our Z. What is the formula for Z calculated? Z calculated is equal to X bar minus mu over standard deviation times square root of n. So in this case, our X bar is 104. 104. Our claimed value of the mean or average is 100. We'll put 100 there. Our standard deviation is 18. We'll put 18 there. And our sample size is 81. So you put 81 there. So you calculate 104 minus 100 is 4. Square root of 81 is 9. 9 into 18 is 2. So as it calculated, 4 over 2 is 2. So you identify whether 2 or 4. Is it in the rejection region or in the accept region? So in this case here, we identify the 2 is somewhere here in the accept region. So what we do, we accept HO. Although at masters we fail to reject HO, it's one and the same thing. And why? Since our Z calculated is less than 2.58. So what is our conclusion? There's no significant difference between 104 and what? And 100. So they're saying 100 on average die in a month. They're telling the truth. So we cannot penalize the hospital for lying. So this is what, in essence, we are talking about. We must also understand this table is very important in calculating our confidence interval. All right, confidence interval is a range within which the values must be accurate. The confidence interval is simply given by the mean plus minus the Z standard deviation over root of n. So if our mean is 10, for instance, we have our standard deviation as 12, and our sample size is 36. Find a 95% confident interval. How do you find a 95% confidence interval? So 95% confidence interval given by the formula above. Our mean is what? 10. Put your 10 there. Our Z from 95 is 1.96. You put 1.96 there. And our standard deviation is 12. You put your 12 there. Square root of n. Our n is what? Our n is 36. You put 36 there. So the square root of 36 is 6. 6 into 12 is 2. So this is our standard error. So 10 plus minus 1.96 times 2. 1.96 times 2. So the 2 here will compute that. So what are we going to have? 1.96 is going to 3.92. We start first by finding the lower bound and the upper bound. So what is 10 minus 3.92? 6.08. And what is 10 plus 3.92? 13.992. So this is our lower bound and upper bound. So it's a range. Okay. Confidence interval, if I say I'll take 10 minutes to come to where you are, plus minus 2, means if you're going to be early, you'll be there in 8 minutes. 10 minus 2. If you're going to be late, You'll be there in 12 minutes, 12 plus 2. So this is what we call a range confidence interval. We can work it up backwards to find the mean, which is our 10. We add the 2. 8 plus 12 is 20 divided by 2, we get 10. If we want to find the error, we subtract the 2. Okay, 12 minus 8 is 4, divided by 2 is 2. Or 8 minus 12 is negative 4 divided by 2. That's why we have a plus minus 2. So our range is simply equal to plus minus the error term, or the margin of error. Okay, so this is the error. So this is called our standard error. Our standard error is simply the standard deviation over square root of n. So when we multiply it by our z value, we get the margin of error. So this is how we find the confidence interval. Sometimes we'll be asked to find the sample size. Sample size is simply given by the z squared, s squared over the error term. Error is the level of precision. You'll be given it in its context. So those are just ad hoc information that you need. What you need to really use that information for is understanding its application in our term project. Right. Now,
I have a question.
yes, there's a question, okay?
Sorry, bring back the, yes. When we found the the SL.
Confidence level, yes.
Sorry?
What's the question?
Yes, when we found the SL as 1%, we subtracted the 100 from the 99%.
Okay, all right, so let's get to the
Yes,
basic.
so I want to understand why we
So how do we find those levels of
subtracted.
significance in a nutshell? So first you need to understand how to read. For instance, what is 1.96? 1.96, we read 1.9 here, all right? And 0.06 from above there. So where they meet, what is our 1.96? 0.79750. That is our reading for 1.96. Are we together? And if I tell you this probability of 0.9750, what is the Z? You just give me the figure 1.96 in there. All right, so help me. What is the Z for 0.9871 from that lesson? It's 2.2 and 0.03.
2.1. 2.2, sorry.
2.23, right? So the Z is 2.2 times 0.03, so 2.23. So how we read the Z is simply 1 minus alpha over 2. Okay, you read from inside the table. All right, so if we're dealing with 95%, for instance, what is our alpha for 95%? Is 0.05, isn't it? So 1 minus 0.05 divided by 2. What do we get? We get 0.975. So this is the probability that we have here. So when you read it from inside the table, it will give us a Z of 1.96. Okay? So that is how we got those figures. So I'm trying to simplify your process of recalculating because those are the most common ones. Suppose they gave us what? 98%. 98%. How do we read that one? It's 1 minus alpha over 2. So 98% is 2%. So 1 minus 0.02 divided by 2. So 0.01, which is 0.99. So you need to check for 0.99 inside the table. It will give us what? 2.33. So when you go here, if you don't find the exact one, you get the closest possible. So here, 0.99 is here. So it is 2.33. So these are where the figures are coming from. So I'll send you the video of how to read these things, but that's the shortcut of everything. Okay, so we end here. The next class we're going to look at will be how to calculate the difference between two samples. Then we'll be able to answer our second question in the term test. Right? So we're going to end here. Thank you so much for your time and have a good day. We have management theory and practice at 10 hours.